welcome back to my YouTube channel. And today we'll be discussing CAP theorem. So, why CAP theorem is important and why do we need to know CAP theorem? This CAP theorem is important because before you start designing your system, and I'm talking about system which will be going to handle a high number of traffic and it is highly scalable. I'm talking about millions and billions of users using your system. And then what trade-off you need to consider? Okay, so now you'll say why we need to consider trade-offs. You'll get to know as we go on in this video. We'll discuss it in deep. Let's get started. What does this CAP stands for? CAP stands for consistency, availability, and partition tolerance. So let's see what this is. We'll start with consistency. Let's suppose there are two nodes of a server, okay, and you are doing a put operation on node 1 and saying your amount value is 100, and now you are saying to node 2, hey, get my amount value. So it is returning you the same amount value because there is a sync between node 1 and node 2. Okay, so this sync tells you that your system is consistent. Okay, this sync will ensure your all the nodes are consistent with data. Okay, so what we can do is we'll mark this update only if all the nodes are all the nodes have the updated value. We can do this to ensure highly consistency. Okay, so this is what consistent systems are. Now let's see what availability means. Let's suppose again you have two nodes and there is sync obviously between the nodes, but due to some XYZ reason, your node 2 is down. Now what will happen? Your requests which were going to node 1 will be kept on going to node 1, but the request now which was going to node 2 will be redirected to node 1 only, and node 1 will serve all the traffic. So your system is available. Although your node is down, one of your node is down, but the overall system is up. So this is what availability is. It means, yeah, it means that what if there is some node which is not up or down, it will not impact your overall system. So your system is always available. Okay, now see what partition tolerance is. Partition tolerance says, let's suppose the sync between both the nodes is not happening due to any reason. So now what will happen? Now what will happen is if you do a put request again on amount and say it is 20, and again you do a get request from node 2 of amount, it will return maybe 0 because maybe the earlier value was 0. So it will not give you updated amount, but our system is up now also. It is serving your traffic. So this is what partition tolerance is. If somehow your sync is not happening, then also system is up. Okay. So now you'll say that uh, in all the three scenarios, your system is up, and you always want your system to be highly consistent, available, and partition tolerance. Okay, but this is not uh, this is not possible in a system where you can have all three. I'll tell you why. So let's suppose there is a partition tolerance in your system. As soon as by this what I mean is, let's suppose this sync is not happening due to XYZ reasons. Okay, the both partitions or both nodes are not in sync, they are not able to communicate with each other due to any reason, then you have only two options. First is your system to be highly available, which, as I mentioned you in this example, it is available, it is serving a request. But is this consistent? No, it is not consistent. So you have to choose now between availability and consistency. So you will say that if I want my availability, so what it will do is it will serve your traffic, but wrong data or stale data. But you will say, no, I want my system to be consistent. So what will happen is whenever you will do a put operation, now it will say, it will not, it will give you an error and say, no, I will not do a put operation because I'm not able to connect with another node. So I will not be consistent. So if I am not able to save the data in other nodes, I will not update in any node. So this request will be denied. So like this, you will be able to achieve consistency in partition tolerance. Okay, so for some reason your system is up, but it is giving in an error that no, I will not able to update. Okay, so this is what you have to choose. This is a trade-off you have to make whenever you are designing any system. You cannot have both availability and consistency in case there is a sync gap between the multi-node. Okay, so if there is any sync gap between two nodes, you have to decide this. Let me tell you by an example. Um, uh, for example, you are building a system for bank, okay, where you will be dealing with currencies, or you are making an inventory system where you have to deal with this number of items available, or stocks are there for a number of how many items are available in the stock. In that case, you cannot uh, go have a trade, or you cannot ignore this consistency. Okay, you have to have consistency whatsoever happens. Maybe your system is not available, you are not able to update, but then also you have to have consistency always. Okay, but if you are building a system like timeline service, or or just a listing page, a scrolling page, that kind of services you are building, you are okay with consistency. So okay, for a particular period of time, I will get sale data, but I have to serve my request to my customers. Okay, I cannot take a hit on the downtime. Like if you are having an e-commerce website, you have to show the PDP page, you have to show the listing pages if they are searching any product. Let's suppose you have done made an update on the product, maybe the old data is coming, but then also customers are seeing that data, they are getting their request served. So in that cases, you cannot take hit on a business. So you will keep a system highly available, although the consistency is not there. Okay, so this is what you have to take care of. In terms of databases, if you see, we or everyone will say that SQL databases are very much consistent, but yes, they are not highly available. We can make them highly available through read replicas, but then also, if you're making them highly available through read replicas and there is a sync gap, you may get shell data. So if you have to choose between consistency and availability every time, and you will see that NoSQL databases are very much available. They are not that much consistent as a SQL databases, but they are very much available in terms. So how can we achieve that availability? I'll create a video where I'll explain how NoSQL databases are so much highly available, but they are not consistent. Obviously, they are eventually consistent. I'll let you know what eventual consistency means. Okay, but yeah, um, so if you want to design a system in the start only, you have to think of a trade-off between consistency and availability, because you cannot have all three. This is what it is. So I hope you like this video. uh, Please let me know if you want to discuss on any other topic. I'll be creating videos on how to design a NoSQL, how NoSQL databases are so much scalable. Then I will also let you know how and when to choose SQL and when not to choose SQL, when to go for NoSQL database. There are multiple type of NoSQL databases also, like columnar, key value pair, document base, graph database. So I'll let you know when to choose what. Okay, so till then, uh, take care.